industry news, machine reviews, interviews, and a lot more right here on the World Like Bazza podcast.
The World Like Bazza podcast, episode 6, Mark Kendall. This week I sit down with Mark Kendall, a person I've respected very highly from the start of my career in the welding industry. Mark's the director at Pullman Instruments and is quite literally what I will class as the gold standard when it comes to calibration, the science, technology, and the how behind it. I finished this interview knowing Mark would be yet another regular on the show. I also felt the interview in itself was a verification of my own capabilities and knowledge in this field. If you're new to the show, welcome. If you're a returning listener, thanks for coming back. Quick note, Tuesday the 27th of February would have been Dad's 64th birthday. Wherever you're listening, Dad, happy birthday. We'll love you more than ever. Now, welcome along to episode 6 of the World Like Bazza podcast.
The World Like Bazza podcast is sponsored by MS Welding, the #1 welding solution provider. mswelding.co.uk.
So yeah, target audience. It started out as a joke. I had a rep who came in to see me, and he were like, "You need a caricature."
Right. You need an avatar.
Yeah, you need an avatar. and it kind of came across as, he really supported me, did Gary, when my dad were in hospital, and he'd phone me up and he'd phone my dad in hospital.
Yeah.
And he were kind of going, is he what you need? And it got to a point, those last few weeks of like, guys, I needed some of the wire dropping in at work, or I need some stuff. And it just, without them guys, I don't think I'd have been able to just, facilitate everything that I needed to do.
Yeah.
So this all came from, you need an avatar. And I said, well, I've always wanted to do a podcast.
Yeah.
And they're all laughing about it. And I said, well, I worked on radio as an hobby forever since being 40.
Did you?
Oh, yeah.
Really?
So did you not know that?
No, I didn't know that.
So I think where we'll start is my first meeting of you. I think we're in a little office with Colin.
Yes.
Very shortly after I passed my driving test.
Yeah, I remember that.
Do you?
Yeah.
So what happened is my dad said, I can't wait for you to become a driver and pass your driving test because I can get you out in van.
Get you out on the road, yeah.
And that's how it happened. So how did it start for you? How did you and Colin meet?
So my dad and Colin were friends.
Right.
They knew each other. They'd kind of worked a little bit together. They religiously, they attended the same church.
Right.
So did I. And they'd kind of worked alongside each other in certain capacities there.
Right.
I think for me as a kid, I had itchy fingers. I was tactile. I loved touching stuff. I loved looking at stuff. I actually loved taking stuff apart. Problem was I could never put it back together.
Okay.
So my dad thought to myself, right, that's it. I'm going to get you a job where you can learn how to do this stuff.
Right.
So, and Colin he'd started working for a company in Leeds, A&J Electrics. And what they'd done is they'd started it's like a wholesale business, but they were passing on services to wholesalers, electrical wholesalers and people like that. And they started to look at building, supporting, selling equipment, and then calibration started to take off.
So what years are this?
Probably 1981, 82.
Okay.
And then I left school in 1982. Well, pretty much 6 months before I left school, Colin and my dad had already shook hands. I didn't even know this.
Right, like an arranged marriage?
Yeah. They said, right, YTS, he can come for 6 months and learn a skill. So Colin agreed it. So I pretty much, before I left school, I thought to myself, well, I've got somewhere to go. My career path, I didn't know what it looked like, but at least I thought I'd have to worry about thinking, what am I going to do? Because I've already got something in mind. I did apply for a job at Barnbow, but I don't know how I'd fare working in a factory.
Right.
And I didn't get it. There were just so many people that applied for it, and I think it was a very, rigorous selection process. Actually, I think a lot of it was more a case of if you had relatives that worked there, you got the job, you know what I mean?
Yes.
They just were going through that due process. And I just literally 2 weeks after I left school in July, I was in Harrogate working. I had 2 weeks off, that was it. 10th of August 1982, I started work.
Amazing.
And at that point, I came into a job where I literally started right at the brass tacks. I was a guy that was cleaning up instruments, you know what I mean?
Okay, yeah.
Dirty units that came in from customers, we'd have to spray them with foam, clean them, They'd get tested, then we'd have to clean them and label them. I was a dog's body.
And instruments at this point, what we're talking about? Multimeters?
Avos, the old Avos.
Well, my dad's got one on his bench.
Yeah, the old Avo miners, Avo multimeters.
Right.
Some of the old Evershed and Vignal Megas.
I'm surprised you don't have any set up in here.
We do have a display cabinet, but we don't. We've got some, but we just never put it in. We've never put them in.
Get an old Mega in there. That'd be great.
Yeah. I mean, honestly, some of this stuff is heritage stuff.
Yeah, it is. And is that how you grew up? So you learned at that point, were you not just a dog's body, but as you progressed, did you start taking this stuff apart?
There was always the intention. Colin wanted us to come in and learn the ropes. He wanted us to start doing the simple things, but actually start to develop. And I don't know, for whatever reason, I just found it really, I started to develop, I started to look at, again, taking stuff apart, but I started to learn how to put them back together, how to fault find, how to fix, how to test, using the calibrators, using all of the technologies that were available at the time, which was it was really analog. It was all rotating dials to generate your output signals and pressing buttons to actually turn it on and off. None of this, in a computer, a laptop, so that it actually controls it via a PC.
Which is how you do things now.
And actually, to be honest, everything is all driven by a piece of software.
Right.
Actually, I think you learn more when you're doing it analog.
The way that I've done it, the way that you've done it.
Analog you can't avoid the fact that you've got to think about what you're doing. Computers take that thinking element out of it.
So how long did that last? So you and Colin, what was it? Just you two at that point?
So he had a business partner, David Cooper, at the time. So they they owned that company. Pullman Instruments started. Yeah. They were the co-owners. David worked in the lab. Colin was obviously the business driver, so he would look at going out and getting new customers.
Okay.
And what I did then was I kind of supported David in getting whatever came in. We'd book instruments in, we'd get them on the bench, we'd calibrate them, any that were faulty we'd fix, and then they'd go out. And Colin was actually very much an instigator of this 5-day delivery service because nobody really thought about service deliveries at that time.
Okay.
It wasn't something that was a big seller. Because I don't think anybody drove it, to be honest. People just got the stuff back when they got the stuff back.
Right.
But he saw the need for setting dates. So you set a 5-day schedule, you stick to that 5-day schedule, your customer gets the work back. They've actually built their business around knowing that I've got to look at my equipment being away for a week, but I know it's coming back. So I can plan my work around it. So And guess what? You look at pretty much every other calibration company now, 5-day service.
Right. And
some people say 3 days or less. And yeah, good luck with that, because I know what that looks like.
Especially if you're doing a UCAS calibration.
Oh yeah, you're never going to do it. You need 24 hours for it to stabilise before you can even test.
So when did you first meet my dad?
So your dad used to work for, was it AA Welding?
AA Welding, yeah.
It was not long after that, because I went out with Colin. So not just in the goods in and the lab area, or the what we considered the lab at that time. Colin would take us out. He took me out, and it was at that point I met your dad at first when he was at AA. Right. So we went to see. I can't remember what the guy was called. Trevor. That's right. Yeah. And of course your dad was there.
Yeah. His dad was service manager for Trevor.
He was service manager there. And then I think the next time I met him was when he'd stepped away and started up on his own.
So that would have been, I think it was late 80s, wasn't it, when that happened?
Yeah, about 86, 87. 87, something like that.
And then I left school, that would have been 96, 97. And the minute he could get me in the van, right, brilliant, you can earn money for business.
Yeah.
And one of my first jobs were, sat-nav didn't exist then. It was, get yourself to Harrogate, you need to go get me some meters picked up from Mark.
Yeah, I don't know if your dad was the same as Colin, but Colin, because I used to do some driving for him as well, but he'd draw these maps on back of A4 pieces of paper. Yeah. And you'd be looking at this map and thinking, I still can't work out where you want me to go.
Well, there's a brilliant story that leads to. he were in a bad mood one day and he said, these bits need dropping at a place, and he didn't even know the name at company. And he went, it's just round back of Ken Plants. So Ken Plants were in Cleckheaton, and I thought, how can it be round back of Ken Plants? So I don't even think I had a mobile phone at this point. And I'm driving round and thinking there's no business round here. And I pulled over, I ended up going into a business, and it were about 7 miles in opposite direction. And I got back to work and he were like, where have you been? And I went, you know that place, don't you? Right round back of Ken Plants. And we were laughing about that even week before he passed away. We were still laughing about Ken Plants and that place round back of it.
Those maps were ace. You ask any of the guys, Tony Cox, Mark Conboy, they'll all tell you that those maps were legendary.
They're much better than sat-nav.
But he'd draw the roads, and then he'd do the roundabouts, and he'd have every turn off.
You need to be on here.
And the arrows would point you to where you're going. And actually, to be honest, they usually worked quite well.
A lot better than sat-nav.
Yeah, probably.
So, and at that point, was that just one office, I remember? Was it one office in Harrogate?
Yeah. So we started in... Albert Hymas is like a goods delivery vehicle. So they have a lot of trucks. They had a lot of pickup trucks, dumper trucks.
Right.
And there was a yard in Harrogate that they used as a storage area for the trucks.
Right.
And Hymas's yard, Colin, had a little, 2 rooms basically when we first started. So an office at the front and where we used to work in the back, which was just a scabby little room, really, with benches all round, and then these drawers in the middle where we'd sit, work on top, and, it was nothing to look at. But it was a starting point, and slowly but surely. So I started in 82. Mark Conboy, who's still here, started in 84. Right. So he was 2 years after me.
Yeah.
So we started to get bums on seats and started to fill the room up, and you could tell that, okay, we can't fit in here anymore.
Okay,
there's not enough room.
And that's been a story that's just evolved every time you move to a new premises.
Yeah. It's almost like every time we've moved into a new place, we've plugged the gap, filled it, and then we've all right, well, I think it's time we moved out now.
Yeah,
and we've only been here a year, and we're at a point where we're thinking we ain't got enough space.
Is that right? That we're there now already?
Yeah, pretty much.
So right back to calibration. Somebody comes in with an old Evo and it needs calibrating. You need to put a certificate on it. At that point, were you working to standards, or was that something that you derived yourself?
BS 5750.
That's what we used to calibrate to at that point. All that time ago.
And BS 5781, which I think turned into 10,012, and obviously 5750 is now the 9001 standard.
Yeah, for the ISO.
That was the old terminology for the actual standard for calibrating equipment. So it was that process of, you need to make sure that you can validate your paperwork. You need to make sure you've got a process in place for point of entry to point of exit and every step that happens in between.
Right. So is that important in your kind of...
Without a doubt, because that's an audit trail.
Right.
Every point in that process, and it hasn't changed. The thing is, things are more visible now because the standards have become more rigorous.
Right.
But it's still governance over point of entry to point of exit and every step that goes on in between.
Okay.
Realistically, now it's about indemnifying what that customer is using that equipment for. So all of those steps need to be absolutely on the money.
Okay, and I guess somebody who comes in with like a new fluke meter like I bought last year, they might have a different use for that meter.
Yeah.
And so does that, you were just saying that indemnifying there what that client's using it for. Yeah. Are you trying to make it specific so that's as accurate as can be for that client's use?
So there's 2 rules of thumb, okay? Generally, calibration requires that you calibrate to manufacturer's tolerance across all of its ranges.
Right.
That's to meet a manufacturer's specification. But if your customer wants something that's more specific and ain't bothered, because he never uses a multimeter on temperature or capacitance, then why is he actually wanting a set of values on that multimeter?
And it takes you longer to do that.
It takes us longer to do it. So the customer can specify what it is that they want.
And that's legal. That's legal to do.
Absolutely legitimate. So long as that customer gives us a document that says, this is my requirement. They create what's called a contract document. Okay. So that contract document is, they stipulate the parameters that we work to.
Right.
And the general rule of thumb is if they don't tell us, then we'll work to manufacturer specification. That is the industry standard. That's the standard default.
Right.
But we do have a lot of customers that tell us, well, we don't want to work to that. We want this, this and this to be done.
Okay.
So what we have to do is we have to create a different procedure process. We have to identify it as a specific procedure for that customer, because otherwise we don't know in the lab if they're going to choose the right process to meet the right requirements for that client.
And that becomes a problem when how many pieces of equipment are going through in a week?
Yeah, so in a week, we're probably doing, how many weeks a year? 50. We're doing maybe 1,500 to 2,000 units a week.
With how many engineers?
Yeah, as it stands at the moment, we've got 4 here that are doing calibrations full time. We've got 3 at other offices, but generally they're only 50% productive. They've got limited capabilities. What they don't do comes here.
Right.
So we've got 4 engineers that are full time, turning out a lot of work.
That's some items of equipment.
Yeah, definitely.
Is that 12-hour days or?
No. They try to do it in 8 hours. Some of us do 12 hours because we play catch up now and again.
Very much so.
Unfortunately, not everybody's quite as what's the right word? They're committed in the same way that perhaps some are.
Yeah.
They're less committed than we might be because we're a little bit more entrenched in what goes on in the business. And guess what? People, they have their own lives to live. Yeah. And realistically, we're never in a position to be compelling them to do this. We can't.
So do you still jump on tools?
Oh, yeah, I was in there yesterday.
Amazing. That's brilliant. So I like to hear that.
Two function generators for one of our clients yesterday.
Right, okay.
Nobody could work out how to do the distortion tests on them. And bear in mind, Barrett, last time I went in that lab to do something like this was 15 years ago.
Right, okay.
I'm sat there scratching my head thinking, I can't remember what buttons to press.
So talk me through a function generator then. What came in yesterday? What was it? So
there were 2 Instatek AFG 2005 function generator, arbitrary waveform generators. So basically, they'll generate a sine, a square, and a triangular output.
Yeah, triangular output.
Yeah, they'll do from 10 hertz to 5 megs. So obviously, you've got to do your frequency sweep. You'll do all of your tests across 5, 6, 7, 8 or 9 points.
Depending on how big that range is.
Yeah, it depends on the range. And actually, you kind of look at the unit as well. If it's only a £400 unit, you wouldn't spend 5 hours doing 20 pages of, you just don't. So you have to do the frequency side to make sure that it meets its 10 ppm spec or whatever it is.
Right.
So obviously we've got counters next door that can read down to 10 or 12 decimal places, and they're crystal locked. So they actually are linked to an atomic clock. An atomic clock. So we've got an atomic reference clock in the lab.
Is that something you had to do?
Yeah, you've got to do it because otherwise when you're actually measuring an oscillator, then that oscillator has a performance characteristic.
Yeah.
But the device that you're measuring is very similar.
Yes.
So if you don't crystal lock or create some kind of way of accurately improving the reference of that unit, then you're only really doing a verification. You're doing tests on something that's very similar. So but your 10 meg reference means that you're immediately locking it to something that is pretty much an NPL standard.
Yeah, and that atomic clock, that's set as a standard because we know that whatever's in that atomic clock does that.
It don't vary.
It's been proven.
Yeah, and you look at the performance of the function, the frequency counter that we use. It's a HP unit. The atomic clock has a number of steps, factors of accuracy better than the machine that we're using to test the function generator that's 4 or 5 times less accurate anyway. So all of those steps, that's the validation process. The verification process and the confidence process is about what we're testing versus what we're using and what we can actually make sure we verify it against or lock it to.
Yeah.
So that's why we use an atomic clock, rubidium standard.
That's really good.
Yeah.
And I bet there's so many people who... I talk about calibration from one avenue, which is of the welding equipment.
Yeah.
And I get into some really deep discussions, and it happened only last week where I was like, I don't want to say it, but I think what you're saying is wrong.
Right.
And I don't want to say it, but I listen to people, and I think they take a very small amount of the information.
Yeah.
And they utilise that very small information to make it work for them.
Yeah.
And a lot of people that do calibration within the welding industry turn up with just a big old unit. It's got 2 digital meters in there.
A shunt and a voltmeter.
A shunt and a voltmeter.
Yeah.
And it's
a Sterling validators.
So back to AA welding.
Yeah.
But the
Sterling validators.
The new model. And then somebody turned around to me. I went to a Genset open day, and it was like a training open day with some engineers from Italy. And they got the new version of the Sterling validator because Trevor passed away.
Yeah.
So Matt's taken over SMP, and he builds his own, and it's nice. It's plugs into mains and everything, just like Trevor's did. And somebody said to me, "So what do you use?" And I went, "Fluke." It used to be my Monaco, that were on my dad's bench. A Fluke, a clamp meter, a resistive load bank, 1 meter measured cables. And they go, "Well, how's your clamp meter as accurate as that Sterling validator reference?" And I'm like, "Well, ultimately it's got 4.5 times, so it's 2.5 times higher resolution than what measure."
Yeah, so the validators are 1 decimal place.
Yeah, and I go to like
3. Yeah.
And on my voltmeter, it's a 4.5 digit.
Yeah.
And when you talk about that, you instantly see engineers go, "What is he talking about?" But that's in the standard.
Yeah.
I've got to work to that in the standard if you read it back to front.
Yeah, and I guess if you look at what you would consider to be the industry standard as far as that type of unit, the validators, they are very low resolution. They do connect to a shunt.
Yeah.
But actually the shunt's better than the meter can actually read. So why would you not have a display that's already got 3 decimal places? Your shunt is 0.5%.
Is that the accuracy?
Yeah, generally you can get 1%, but normally 0.5% on your shunts. But you're connecting it to a meter that can't even read the sort of characteristics that shunt's actually producing.
And the resolution will be nowhere near.
That's the issue. So your 0.5% at, let's say, 10 amps is 50 milliamps, but your Sterling validator will only read 100 milliamps.
Yeah.
So you can't even see what the performance characteristics might be on that shunt in real time.
Right. And
whereas you can with a multimeter that's doing the same job.
And I would prefer to take a little bit longer, and I get everything racked out, and I get my load bank out, and I put my meters in, and then I put my voltmeter in, I get my clamp meter on, and I've even seen over the last few years, every time I buy a new clamp meter, which is every couple of years, even that becomes more accurate.
Yeah.
And ultimately, all I'm doing is saying, when John welds at 100 amps, it's definitely 100 amps.
Yeah.
But I like to look at it from a different point of view, that in olden days, when we had analog meters with a moving coil, it was done slightly differently, because you'd want to try and get full scale deflection. Whereas now, you don't know what full scale deflection is, because you've got a digital meter that's probably in a wire feed unit of a welding machine.
Yeah.
Whereas your kind of calibration, if that meter's going to read voltage up to 1,000 volts, you want to be able to calibrate and validate that.
Well, we've got to produce a source that is doing so we'll hang our hat on whatever our equipment says.
Yes.
So we're generating 1,000 volts that meter's reading. So we have to be sure that 1,000 volts is a real 1,000 volts.
Which is the really interesting part that I want to get to. So how do we determine the chicken and the egg?
How do we determine the chicken and the egg? Right. So how do Pullman instruments go about calibrating equipment?
How do you make sure a volt is a volt?
Right.
How do you make sure 1 meg is 1 meg?
Right.
How do you make sure 1,000 amps is 1,000 amps? And then we'll start talking about other stuff you do.
Okay, so here's the interesting bit. We either have to be sure of the equipment that we're using to measure that, because we've got to validate the work that we do. So when we're doing UCAS work, every measurement that we make, we have to triangulate against 2 other pieces of equipment.
So you're not just checking it with 1 piece of equipment when you check mine.
So an output has to be verified against 2 other multimeters.
So I bring my Fluke in, and you're checking that at 100 volts, AC. You've got another 2 meters in there.
So what we'll have done is the calibrator that we use to issue that UCAS certificate, right?
Yeah.
Where we know what that output is, because we've got a budget that tells us what that output is.
Right.
We've already done the work to make sure that when we say that that's got an uncertainty that might be 0.5% or whatever it is, that we've made up that contribution from the work that we've done with those other 2 meters.
Okay.
So that's the triangulation process. You have to verify using 2 different machines to make sure that actually they can replicate the same values, so that when we press that button, we know what we're producing.
And that's really interesting, because we obviously get all our stuff done to UCAS. A lot of people that get them Sterling validator type calibrating machines just send them back to the manufacturer, and they just put it back into whatever. It might hook it up to another welding machine. They're not triangulating that, are they? That's just probably being checked with 1 meter.
So what they may have is similar to what you're doing. They might have it connected to a load bank, and that's in line with it. Yeah. It's no different to what you're doing.
No.
But they're using a source, and you don't know what that source is referenced back to. You know, they could be using, you don't know, Barry, they could be using a clamp meter and a shunt and a multimeter themselves.
Yeah.
You just don't know, do you?
But that's okay in my situation. I can't really do, because I'm calibrating the welder. Yeah. I'm not bothered about the instruments. I'm calibrating the welder. I just want to make sure that you've calibrated my instruments to the best we can have them done. Yeah. Because my welding machine needs to give 100 amps or 200 amps, and at 200 amps it needs to be, if it's constant voltage profile, we need to be running at 24 volts. And I need to make sure that relates.
So let's look at what you do versus what we do. So if you're out in the field and you're coming along and you're going to test some welders for one of your customers, the first thing that you've got to consider that you don't even probably know about is actually you connect those welders up to a supply. Yep. They automatically have an impact on that supply. Yep. So they'll potentially load it, and they'll create reflective harmonics back on that supply. Yeah,
reflective harmonics, back EMF.
Yeah, back EMF, harmonics, because it's actually a highly inductive load.
It is indeed.
But that then also affects the performance.
And your reading equipment as well.
Yeah, and
I think that's quite often I'll see somebody fail a machine, or they'll say something's failed, and I'll kind of think, but they don't actually, all they've seen is they've not been able to get the reading they want. Yeah. And they've not understood what's gone on. Is the meter reading actually fault? Is a machine faulty?
Yeah, what's that contribution made up of?
And then I'll have a look at that and go, well, the balance is completely swung the wrong way on the AC waveform, which is positive and negative DC switching on my machine. So you're actually
clipping it.
And they're clipping it, and their meter might not be able to read the frequency that the output will match
so your Fluke multimeter is incredibly good on crest factor. Yeah. Which means it doesn't matter what that waveform looks like, it can interrogate it.
Yeah, and I could make my process better by using like the old Chevy Nanu system that I actually plug into my Fluke, couldn't I? Yeah. And use that Fluke as my reference for my Chevy Nanu or my clamp.
Yeah. Again, that means that you're triangulating to some degree what you're doing. Yeah. So the difference for us is our lab has to have a stable mains supply.
So have you got
we've got mains filters on
main filters in?
Yeah, mains filters. Because if it's not stable, we're generating, voltages and currents that are down to 8.5 digits.
Yes.
So even the slightest little bit of noise can actually create anomalies in that process, in that result. Yeah. And if we don't make sure that what we're doing is protecting the process by looking at every aspect of it, including the main supply, we can't guarantee what's going to come out at the end. So we have got to be really rigid in what we do to support the evidence that we produce at the end of it on a certificate.
And that's so interesting, because I'd like to. Obviously, I'm really geeky about what I do, and it's not a case of just turning up with a clamp meter and a voltmeter. I want to make sure that I do it to the very best. And when I do get these, like you've said, anomalies, these readings that don't always look like they comply, I want to, before I say it's failed, I want to know why. Yeah. And I want to make sure that it's not a false reading. Yeah. On a welding machine, if you've got 30 to do and you've got 2 days to do them in, you're going to be checking your main supply and you're going to check your voltage input. And that's the least you can do. And that's on the charts. You've got to do that. Yeah. But at that point, I will really try and flex the machine to its very biggest potential. And I know that some welding machines don't like a resistive load in certain processes. So I know that I've got to I'm not saying that machine's not calibrated, but what I'd do is I'd put that into maybe a constant current.
Yeah.
Because I know the IGBTs in that machine give out loads of noise at a certain point.
Yeah.
You know, and it might not be noisy at 100 amps, but I know at 270 amps, approaching 300 amps, it starts to get noise.
Yeah, so that the components internally are starting to
saturate.
They're being stressed.
Yeah, they're either saturating or they're becoming very inefficient.
Inefficient, that's right.
Yeah. And when I talk about this, I do often think there's quite a lot of people, engineers in industry, that think Barry's just talking crap.
Yeah.
And it's good to have this conversation because I look at it, it's not like a millisynchrowave that had a transformer.
But any component has a limitation to it.
It does.
Right? And when you get to the point of saturation, you're actually stressing it to the point where it'll break.
And that's what happens with welding machines.
Yeah. So realistically, you're not wrong. You know, you push it to the limit. You stress test something. It may well do it.
Yeah.
But at some point in time, it'll give.
It will.
And some it will let go. And it's usually the weakest component in link.
Yeah. IGBTs.
Your capacitors, your protection devices.
Yes.
Some it lets go. And it's doing the right thing because it's there to protect the machine.
Yeah.
But at the end of the day, you've got to know what it is that you're dealing with, haven't you?
Yes.
You've got to know the workarounds because you already know what the weaknesses are intrinsic in that machine.
And this is how geeky I am. Before I went out to my genset training few days, I got my power book out and I was re-educating myself on direction of magnetic flux.
Oh, yeah.
Because that's how I am. And then when I spoke about that to people, they kind of looked at me as if to say, flux? Isn't that something you use when you silver soldering?
Yeah, they don't know what Gauss means, do
and
they?
I was like, there's a time when I need to shut up. But these conversations really good with you because you talk on my level.
I'm a bit geeky myself. We're just working on putting some Helmholtz coils in where we can actually generate directional magnetic fields so we can calibrate mag meters, Gauss meters. So
how are you going to do that? Have you designed the coils yourself?
No, you can buy them.
Right.
But you've got to be... honestly, it's a really weird science, is this? And my head's starting to hurt a little bit with it, but I'm getting there. Cable, believe it or not, wire, copper wire or metal wire.
Yeah.
It's a great conductor, but the one thing that does affect it is frequency.
Yes.
So actually, if you try to drive 100 kilohertz into a coil, you've no chance because it'll saturate it. And
really quickly.
You don't get any output from it. You don't get what you'd expect to be the right characteristics.
Okay.
But you can buy wire that's specifically built so that it'll drive up to 5 megs.
Right.
And you can drive it at 10 amps.
So what will be different about that?
The difference is that what we'll be generating is a fixed frequency, a fixed current on 2 parallel coils. And when they're running side by side, what they do is they generate a magnetic field.
Right.
So we will actually have a direct, and it depends which way we drive it. So if we drive it positive, it might flow left to right. If we drive it negative, it might flow right to left.
Okay.
So we can create directional magnetic fields.
This is interesting.
And I'm having to do it because we've got to test some clamp meters for rail industry that are running at 165 kilohertz. But I can't do it.
So what will those clamp meters be used for?
So they're used on track protection warning system on trains.
Right, okay.
So they have a system that's built into the forefoot so between the tracks.
Yeah.
And this tells the system the position of the train on the track.
Okay.
And if they're out of position or something's wrong or there's an alarm that's triggered somewhere, then that system can actually force the train to stop. It can engage different modes in the train.
Oh, wow.
So they run at 165 kilohertz and then they've got 4 or 5 different frequencies that operate above and below that control different processes in the train. So emergency stop, brake, release, all of that. And whereas normally, so what happened if a train driver collapsed, had a heart attack, and they went through one of these zones, they can take over and control the braking system on the train. So we've got to test this clamp meter that's actually measuring that resonant frequency that actually, I can't remember if it's been transmitted down the line. I think it is
transmitted down the line?
Oh, on the rail, yeah. Yeah.
So what are they using to transmit that?
Yeah. Great.
That's a question.
There's some of it that's transmitted down the line and then there's some of it that's in the forefoot on loops. So yeah, but The bit that we've got to test is it's a big conductor, just a metal bar.
Right.
That they measure this resonant frequency on the
and this
rolling
clamp
stock.
meter, as it does,
sits around it, yeah.
Yeah, and it's very similar to mine. You just put it over, and
it only measures about 12 amps, I think. But it's like 165 kilohertz.
And what model do they use? What piece of equipment do they use?
It's a TCA Mark II unit.
Is that like...
It's a totally unique, totally bespoke to rail industry.
Right.
So, yeah, we have a number of clients that have got them, and these things cost a fortune to get calibrated.
I can,
£1,000.
Because you need to provide all that gear to
Well, essentially, the company that makes them and calibrates them controls the narrative on what that machine looks like. But actually, if I can produce a signal into a coil that I know can resonate at 165 kilohertz, I can test it myself.
How do we know it's 165 kilohertz?
There you go. That's the question. Because I'll have to monitor it.
It's
again, everything that I do, I've got to I can't second guess.
It's got to be triangulation.
I'll be referencing it to somewhat like a Rogowski coil,
right?
Which will actually work up to. I think some of them can run up to 1 or 2 megs.
I had to learn about magnetism when my dad sent me out to look at a bench unit, a Magnaflux bench unit, and it was 1940s, huge thing. And it's just a massive, massive, massive transformer.
Yeah.
And it's the thing, how they regulate the current, it's on a big variable variable transformer, yeah.
Yeah, variac.
And it's really funny. For some reason, they had a little drive in and it oscillates between 2 points, so it doesn't stick at one point for too long.
Yeah.
And then when you energize it, it makes your eyes flutter a little bit and you can feel it actually do stuff to clamp meter in your hand.
Yeah, yeah.
And if you've got something steel in your hand, I sometimes feel my keys move towards the coil.
Don't wear a watch because it'll wipe it out.
Completely.
Yeah.
But I'm dealing with that. If I'm doing a 500 amp machine, it's maxed out at 450 amps on load. You can start to see magnetism in cables and iron filings standing up.
Yeah.
And it's interesting.
Yeah.
You know, but again, I want to know why that happens.
Yeah.
I don't just want to put my load in.
Yeah, it's even worse if you wind a coil.
Yeah, because it magnetises it every time.
It amplifies it.
And on this Magnaflux unit, they have 10 coils on, so it comes off and they coil it 10 times.
Yeah.
And they use it for testing fractures in things that might have been machined.
Yeah, so it's crack detection.
Yeah. I wouldn't want to be doing that job out all day.
No. Yeah.
So what's really interesting that you've kind of, because I know that you develop a lot of stuff. So like I know that my dad built a transformer that delivered 1 volt, but 1200 amps.
Yeah.
So he could verify stuff. So he could say, I just want to double check that my current meters are working fine.
Yeah.
So what have you built and what do you do?
We still use that. Your dad built us one of them. We still use it.
No way. Yeah, my dad built you one.
Yeah, he built exactly because I asked him to. We asked him to put us one together, and he did. We still use it now.
I remember.
Yeah,
grey box.
Grey box.
6 sockets up
front.
Yeah.
DC out, plus and minus, and then
you run it off AC variac.
Well, we run it off of a pulse width modulating power supply.
Is it right?
So it's a Kikasui unit.
And for people who like listen from maybe the welding side of it, a PMW in a way is biggest part of your welding inverters.
Yeah, of course it is. Yeah,
biggest part of your welding inverters.
Yeah.
But we have 2. We have a primary inverter and a secondary inverter.
So it's just a smooth signal source that generates 230 volts that actually we know is not going to clip or it's not going to be influenced by load. Because obviously your transformer, your primary side, it is influenced to some degree by your secondary, but it's your secondary bit that's doing the damage. You know what I mean?
Yeah.
And that's where alt load is. Your primary is not so.
No. So you also do my meters per minute.
Your tacos?
Yeah.
Yeah.
How do you make sure it's a meter a minute?
You got optical or contact? You got optical, haven't you?
Both. It does both.
Right. Okay. So the contact one we're working on developing at the minute we just use an encoder with a variable speed.
You don't just put it on car tyre at 30 miles an hour?
No. But we're working on putting a system together that's going to do both optical and contact off of the same point of contact on the motor and encoder system. Because obviously all you really need is you contact, your photo side is just simply pulses, so reflective pulses.
Yeah.
So we can produce a wheel, right, that's got 18 degree or 36 degree, 10 of them.
Yeah.
So we can rotate at 10,000 RPM and generate 100,000.
And you know exactly how many pulses per minute you're getting. So
the encoder will tell us. And then the contact again, that's what we're reliant on, but it's essentially the same point of contact.
Yeah.
So we know we can generate 10,000 RPM contact and 100,000 RPM optical.
So we've done stuff for you for like vanometers as well.
Oh, we did the tunnel, yeah.
Yeah, so how's that working? How did you verify, again, wind speed? How did you do that?
Well, it was historical, really. When we bought the tunnel, we didn't get the plenum chamber with it, which is the plenum bit that does the volume.
Yes.
And we knew what we wanted. We'd seen the drawings.
Right.
So I kind of thought, well, you know what, Malcolm knows what he's doing. I'll just send him a picture and see if he can knock me a box up.
And that conversation goes from, Bazza, look at this. Can you get this sorted for Mark?
Yeah. Did he pass it over to you, did he?
Yeah.
Well, it works.
Yeah.
You know, we can take it up to, I can't remember if it's 8,500 litres a minute of flow.
Oh, that's quite good.
Yeah.
Really
we need to run it to 9,500, but to do that we need... It's not just the plenum that's the problem; it's the duct size on the tunnel. So at the moment we're running at 250 mil diameter.
Yeah,
we probably need to be running at 350 mil diameter, which is another tunnel entirely.
Well, I've done a lot of work on this because I do basic LEV testing and inspection for the welding side of stuff.
Yeah,
which is why I got my vanometer, and ultimately I only do very basic systems. But it's good to be able to say, look, with this diameter, at this speed, we're moving this much.
So you can, if you went on a 350 mil diameter duct, you could probably run at 50 metres a second.
That's some going, that, isn't it?
Yeah, but you need a fan that can do it and an inverter, a motor and controller that can actually step it accurately.
Brilliant.
And to get it even more accurate, then you do need things like your orifice plates, which is what we use on our tunnels.
And what do they do? What part do they play in?
So the orifices, they are an upstream restrictor.
Right.
But what they help to do is they actually help to create a laminar flow.
Stabilise.
So it straightens it.
Stabilises it, yeah.
So if you look at any kind of motor, whether it's one that is a centrifugal and it's rotating and spinning, and the air's coming off each of those fans, it's coiling.
Yeah.
So it's not straight.
Right.
And if it's a different impeller where it's pushing at the top as it's rotating,
right? Well,
you're getting all the flow at the top, but it's doing the same thing.
Tumbling.
It's tumbling down the tunnel, and essentially the orifice plate stops it, and then forces it through a restricted area.
Okay.
And straightens it because it's a sharp edge. So, but when we bought the tunnel, it was specifically built to a British standard. It has the orifice plates that straighten it, and then it's got another smoothing chamber that goes on the end. So we don't just get the laminar effect off of the orifice. We get the honeycomb smoothing chamber that adds to the stability of the actual air flow as it's coming out.
Fantastic.
And then it's actually venturied, so it comes out of a smoothing chamber and is speeded back up. Because obviously, if you add a smoothing chamber, you slow it down.
Yes. There's got to be some level of restriction due to laws of physics.
Yeah, but if you actually narrow the nozzle, then you create a venturi effect.
Because it's going to start to speed back up.
It compresses it and speeds it back up. But what it doesn't do is it doesn't change the way that it flows.
So it stays in those straight lines.
It's not turbulent.
That's clever. So all this, you're obviously a very clever person. Is it a continuous study for you? Is it something that you strive to do? So at home on a night, while, you know...
I'm not that boring.
No. But are you...
No, but I am constantly thinking about ways to do things, ways to do things differently. What do we need to bring on board? What are we seeing that our customers want?
Right, okay.
So like I said to you earlier, we've just been looking at a vibration shaker.
This is interesting.
To do accelerometers, so hand-arm vibration units.
Right.
So we'll be able to do the triaxials, we'll be able to do single axis. And you know, it's just a fantastic bit of kit.
So once you buy that, will you modify that, or will it come as a...
No, it's just a full kit. It's already a calibrator.
Right.
So basically all of the all of the procedures for most of the PCB units are already pre-programmed.
Right.
We can create our own profiles on vibration sensors. I'm giving my trade secrets away here, but never mind.
And that's really cool.
Yeah, it's a nice bit of kit.
So what kind of people would be wanting a vibration sensor, really?
You think about it, right? Anybody that is working in a manufacturing process where drills, grinders, anything that creates a vibration. They're going to have to, the standards now dictate that they've got to know what their exposure levels are using those tools for their staff.
Right, okay.
So that's one area. So the hand-arm vibration is potentially a big thing for us.
So if I've got a client and he's got 30 grinders or 40 grinders on his shop floor,
he should have a hand-arm vibration tester.
He should be checking those vibrations of the machine.
Yeah, you should be checking them to see what sort of exposures.
So nobody can come to you in a year's time and say, look, I've got
a white finger, yeah, exactly.
Yeah, right, okay.
Or look, I'm shaking because you've exposed me to it too.
Because at that point, it's no good just to turn around and say, well, when I buy that, I know it's fine.
No.
Because you don't know what's happened to it on the shop floor, do you?
No, it could have been dropped, the environment, all of those things, they play a part in ultimately what that, because you can't guarantee the minute that it goes on your shop floor, it's going to stay the same as when it left factory.
Which brings me to, and this isn't just about vibration, this is about everything that needs a calibration. This is why it should be done.
Yeah. Well, do you know what? I've always felt that nobody likes calibration. It's kind of a dirty word.
The welding industry detests
Everybody
it.
wants to avoid it.
Yeah.
But because we live in a world of claims culture-driven people,
yeah,
you have to make sure that you protect what you're doing, and calibration certificates are an indemnified document. They have to be able to stand up in court.
Yeah.
So somebody say to you, Barry, well, I want evidence of your equipment that you use to calibrate my machine because I don't believe that it worked.
Which is why I always come to you.
That's your audit trail.
And why I always pay for UCAS.
Yeah, that's your audit trail. Yeah. Your audit trail is the bit that protects the integrity of your business.
And my dad always said that UCAS, it's once removed from egg, in his opinion. Yeah. It's as close to the standard as you can get. And that's why we always do UCAS, whereas I know you've got to have try and explain now, the UCAS trail, that's a completely different entrance and exit point to the company, is it?
Yeah. And the thing is that not everybody understands the difference between what a traceable calibration looks like and what a UCAS calibration looks like.
Okay, so explain.
So UCAS has changed over the last probably 4 or 5 years.
Right.
It used to be that companies were allowed to make declarations of conformity on UCAS certificates, right?
Right.
But UCAS have said, but it's not your job to do that. You're already producing a document that issues a set of results and you are stipulating to that client at that point what your uncertainties look like on the measurements that you make.
Right.
It's up to your customer to determine whether that unit's fit for purpose. And that's what's changed. Okay. They then had to bring out something called a decision rule, which meant that actually they realised that most people, forgive me for saying this, but I wonder how many people look at the certificates when they get them back to actually see, is that unit in spec? Especially UCAS ones, because they don't declare a conformity of that unit unless there's a decision rule. Right. So the decision rule is the bit where the customer has to say to us, we want X, Y, and Z at this tolerance across that range. That's the contract review document.
Right.
That means that we will test it to their criteria, and at that point, we can make a statement that says this unit is fit for purpose and passes because we've got parameters to work to.
Yeah.
No parameters means that we just issue a standard declaration of uncertainty against measurements against our uncertainty.
Okay.
That's it.
Right.
Whereas traceable is totally different.
Right, talk me through that.
Traceable is always calibrated to manufacturer's tolerance.
Right.
You can build a procedure that says pass or fail straight away.
Right, which is basically a welding machine is going to pass or fail.
Yeah, see, they're in or out.
Yeah.
And the good thing is that a traceable certificate, you can make that declaration because it's part of your procedure.
Yeah, because I put a sticker on and a ticket, it either says passed or a ticket and it says failed.
Yeah, every traceable certificate that we produce has a column at the end. So on the results page, there's 4 columns. The right-hand column That's your column that says
Passed off.
pass or fail.
Yeah.
Every time.
Yeah.
So actually, it's really easy to read.
Yeah.
It's not ambiguous. Nobody can question the results that have been produced, and it's. I just think that it's better from a confidence point of view that a customer can look at it and think, right, okay, I'm satisfied that I don't need to do any more work on this. When you're dealing with a UCAS, you have the potential for not knowing if it's out.
Yeah.
And then carrying on doing work, which could lead to costly recalls.
Yeah. So I have my UCAS, but as a traceable calibration. So you do mine, and it comes through UCAS, so it's quarantined for a day.
Well, with yours, we already know.
Yeah, exactly.
We've got to meet a spec.
You've got to meet a spec, and I can't go out there, and that's why it always comes here. You understand me as a company and how we do it, which is really important. So, did you tell me once you built a machine for measuring camber on railway, or was this something you started calibrating?
Well, we do track level gauges. We've actually got how many now? I think we've got 3 track level gauge rigs. And
how does that work?
It literally is just a metal box,
right?
2 sections of it, and each section there's a pivot point, and then there's a special plate that, because it's over a set length, they create almost like a profile plate, but it allows you to set cant angles.
Right.
So you lift the bit that's got the bubble on, sit it in 30 degrees, 60 degrees, 90 degree cant angle, and then you sit your track level gauge on, and it's got a bubble on it, and all you do is zero it. And you read off a scale, and it tells you what the angle of elevation is on that track.
Fantastic.
It's a really simple bit of kit. But you know what? It's not, Brunel's technology hasn't changed, because it's still pretty much what he were doing back in 1880 or whatever it was.
1880, yeah.
So, and it was just a 4-foot bar with 2 plates on end that sat on top with a bubble on it.
A bubble in it, because you can't make that line.
Things have changed a little bit, so the machining track now to a better tolerance, because if they don't, it has an impact on the wheel wear on the trains.
Right.
So if they create a nice smooth profile, a P8 profile, then it means, or a P10, or depends on whether it's freight or passenger.
Okay.
So they use different wheels.
Right.
I think generally the rail is pretty much just profiled at P8.
Right.
Which essentially just means it's a slope. It's a 1 in 20 slope that they machine both sides. And the newer track level gauges, they have all of these on.
Right.
So we actually had to then buy another go jig that we sit in, and then we can move one end of it, and it can measure the actual, because there's like limiting markers on the profiles.
Right.
And they're wear indicators, so you've got a pass or a fail, and we can move that part of the jig, and it'll line up with the markers, and it'll tell you whether it's in spec or not. So they're quite bespoke bits of kit. But they there's
an awful lot of investment in calibration, isn't there, to be able to do it properly.
Yeah. I think our spend last year was about £80,000
in upgrading a new equipment.
New equipment, yeah.
Which that's
it's not to be sniffed at.
It's not a small amount of money, is it?
No.
So
and we're fortunate that the chap who owns the business, he's actually seen the progression that's actually come from making those investments.
Right.
You can't, if you don't carry on changing as technologies change and new products come out, and you keep up with the pace of it, if you don't follow it and track it, you get left behind.
I agree. And that was something that Dad always did. He would prefer to have a cabinet full of gear that was relevant for what we were doing.
Yeah.
And buying new stuff all the time.
And what is it? There's a rule of thumb that every 24 months is about the life expectancy of a product before it's changed its iteration and moved on. And
I've noticed that by buying that new Fluke, like the noise suppression at the low end on it, my voltage readings are far more accurate.
Yeah, because it's got a better filtering system built in.
And then obviously we've got that Matrel that we use for the other side of the testing.
Yeah.
That's probably due upgrading. That's probably due a new one, that one, to be fair. And I'll probably look at that at some point, Because that was the old generation when we bought it. We probably had it 10 years.
Still good.
It's still good, but there's probably something newer
Yeah.
that makes it a little bit more accurate
Yeah.
and a little bit more easy.
Yeah.
And again, it's all that proving. You're not just doing it to protect yourself, but you're doing it to prove that evidence throughout that generation. So how many people are here now? How many people do we have?
Harrogate has 37, I think. No, it's 34, and in total, Pullman's employs 37 people. So you look at where we were.
2 people, 3 people.
3 people, 4, pretty much, I would say, when I started, to now having 47 members of staff, and there's 5 labs.
You've been a big driver of that,
for the last 15 years, yeah. Colin retired because he had to.
Right.
He got poorly.
Right.
The intention was always that when I got made a director, I was going to be mentored by Colin.
Right.
So I was going to shadow him for 2 or 3 years, at which point he'd hand over the reins.
Right.
I think 2 weeks after I'd signed the contract and kind of took on the directorship, he'd been not feeling great, and he got ill. He found out he'd got esophageal cancer. And at that point in time, he pretty much just said, right, he said to me, that's it, Mark, it's over to you. I'm not doing this anymore.
Right.
And I don't blame him.
No.
You know, he'd busted his cojones all his life. And why shouldn't he take the time to... Maybe that's what your dad didn't do, you know what I mean? He didn't take enough of a step back and let you take some of the reign.
Dad were really good at applying pressure. We joke about it, but it really wasn't funny. I'd come back off a job where he'd send me out to one job and it completely wouldn't be that job when I got there. And then when I got back, I'd have been stuck in traffic. I'd get back at 6:30, 7 o'clock at night, and he'd be like, I need you to send 5 emails for me. I'd be like, what? Yeah. And he was just like, he knew what he wanted to write in an email, but he just didn't have the time to sit down at a computer and do it. And then I'd be bombarded with that. And then my dad had also lost track, not through his expertise or his knowledge, but it just not having that fight on road daily. Yeah. And then I'd be coming back going, I am absolutely stressed at max and angry about this. And he'd have been in workshop all day.
Yeah.
And I think my dad, if he'd have stopped working, if he'd have taken that step back, he'd have felt like he was giving in to his other illnesses.
Right, do you reckon?
Yeah, completely. Right. And my dad was such a controlling man. I don't mean that in a bad way, but he needed to...
Yeah, but that control made him successful, didn't it?
Very successful.
Yeah.
But the controlling side was like, I'm even going to control absolutely everything about my illnesses.
Yeah.
So when he got diagnosed with rheumatoid arthritis, which wasn't the first major illness, his pernicious anemia was his first one.
Really?
Yeah, so that's when people were coming into work and he thought it was stress himself and probably exhaustion. And this was very early on in my career. We're talking, I'd only just started work, really. And he had staff at that point, quite a lot. He were doing a lot of recondition plant. He were building the meter kits, the analog meter kits.
Yeah.
When welding machines were just fired out into the wilderness without any meters on.
Yeah.
You know, so people couldn't work to procedures unless you bought a meter kit. And my dad, number one, that wasn't good for my dad because he was such a controlling person. He felt that his control was being taken away because he had to run the business and he couldn't do what he wanted to do, which was fix stuff.
Yeah, he wanted to play with skill set.
He just wanted to do, get his tools out of the day. That's what he was good at, and that's what he was really good at. Yeah. And then the control side went further. When he got ill, he went to the doctors, and they didn't know what was wrong. And the doctor was like, "Well, I just don't know what I'm seeing." And she spoke to a haematologist, and he said, "Oh, well, I've got the results here," and they'd lost the label off my dad, and how they realised it with my dad's sample was, "Can you tell me exactly what Mr. Steele looks like?" And the haematologist, from the results he had in the hospital, spoke to the doctor, and from how she described my dad, he knew they were my dad's results. He went, right, that's
a bit of a risk, isn't it?
And he was like, right, get him in. We need more bloods. I'm sure it's Malcolm, and it's pernicious anemia. It's textbook pernicious anemia. And that was where your blood can't... Well, your body doesn't take vitamin B12.
Right.
It's a vital building block.
Oh, of course it is, yeah.
So how he got to that point in his life...
It's terrible because you can absolutely be exhausted because of it, can't you?
Well, he was still carrying on. And apparently when your hemoglobin's at a certain point in your body, you should be laid flat.
Yeah.
My dad was like 10 markers below that and still going into work for 12, 14 hours a day. He just wouldn't give in. It was a driving factor. He wouldn't let anything beat him, be it a circuit board or a welder or an illness.
Yeah.
But that became controllable with a vitamin B12 injection. So he had that vitamin B12 injection, but then when rheumatoid arthritis kicked in, which was another autoimmune system disease, what happened at that point is that requires drugs, that requires serious intervention. So he did everything within his power to control that from, right, I'm going to go completely alcohol-free. I'm not going to drink any alcohol whatsoever. I'm going to have this amount of grapes every night. And I think it completely took over. Yeah. So if he'd have stopped working and taken that step back or said to me at any point, which we laugh about it now, but he was telling all the nurses in the hospital that final week of his life, Barry's been running business now, no problem, and he'd never even given that conversation or responsibility over. Yeah. To me, I was just bombarded with more stress.
Yeah, but it's a needs-must situation, isn't it? And I think it was kind of like that for Colin, unfortunately. I think he just realised that he didn't want to do it anymore.
Right.
He'd done what he needed to, and obviously Nathan had bought business off him, taken over.
Right.
I think he probably just thought, it's their time now. And I was kind of, there was two mindsets that followed on from there, because it would have been nice to have spent a bit more time with Colin, but he's a military man, so he would have wanted me to do things a certain way.
Yes.
I don't think I'd have grown in the way that I have into doing my own way of doing things that's actually proved very successful.
I understand exactly where you're coming from with that, because a lot of my friends that I've trained with and worked with my entire life through different things, and they've always said you've got a very military mindset. Yeah. And that's been installed by my dad being this controlling. My dad wasn't military, but he was very controlling.
So there's autocratic ways of doing things, and it is military men.
We've got there was a lot at my dad's funeral, friends of ours.
Yeah, it's one of those things. It is just very regimental, very routine driven. It's a must. So has to be done this way.
To be done this way.
Can't step outside of the boundaries. But actually, I would say that certainly in the last 5 to 10 years, if you don't innovate, you don't grow.
Do you think because it's Dad's birthday on Tuesday, and it's getting to like the 10-month mark of him not being with us, I can already feel, and I don't want to say this in a disrespectful way, but I can already feel inner growth from my dad not being here. Yeah. So what you said about Colin there, and him being a military man and wanting things to be done in a very rudimentary, very rigid way. Me being able to step out of it and think, right, I'm already 14 hours into my day and I still need to get this done. I'm going to have to do this, this and this, has allowed me to grow, and the business as well.
But you also have to be mindful that you can only sustain that for so long.
Yeah, it's not going to happen forever. We are looking for staff.
And if you can find people that you can trust, that you can employ, that you can hand some of those things over that they can take care of, that gives you the opportunity to be more successful at what you do.
I agree.
Wherever you're doing more of the same stuff, it tends to get in the way.
And is that something that you...
Well, that's something that I think I saw very quickly. And
saw very quickly.
Kind of had to try and learn how to step away from. It's not easy. As a business, we're very system driven. It's a lot of automated processes. We have to follow procedures.
And has that come from you or the industry?
It's driven by the standards a lot of the time, but some of it is we've done internally.
Right.
But things have got to change. You can't. I'll get back to what I said. If you do more of the same stuff all of the time, but you just get busier, you just do more of the same rubbish sometimes.
Yeah, you're not gonna grow. You're not gonna get that innovation.
You don't get that innovation. You don't realise, and you certainly can't see the potential that you've got to do things better.
Because I'm on my knees.
You're too busy.
7 days a week.
Too distracted.
Calibrating and fixing 30-year-old welding machines.
Yeah.
And it would have been likewise for you with Avos.
Yeah. You become very, you're entrenched in what you're doing.
Yeah.
And those blinkers are on, and sometimes you need to be able to step back and look at it and think, okay, so really what should I be doing? If you're in a business,
You need to run
you
the
need
business.
engineers that need to fix the stuff, and you need to run the business. That's the key.
I've tried recruiting this last 10 months. Some people have kind of said, well, I want to take more of a step back in my own life as well, and I know what it's like working, or what it would be like working for you, but we are definitely looking. And I think once we get over this next anniversary and it's been a full year without Dad, then we're going to have to, if I've not found anybody, and I've tried to like literally pull people through the door, we are going to have to get that advertisement out there and get an engineer in, even if it's 4 days a week.
Yeah.
Somebody who wants
Somebody can contribute a little.
4 days a week could be a massive, somebody who can be in the workshop doing stuff 4 days a week.
Have you spoke to colleges and stuff, universities?
I haven't spoken to any universities.
I know graduates aren't always the answer, and they tend to. There's a difference between having academic skills and having life and industry and experiential skills. They're different.
Yeah.
But at least you might find somebody that's got some of the components that you need that you can build on.
Somebody who knows what mains voltage is.
Yeah, say what Volthampton Ohms looks like.
There we go, we're happy.
Yeah.
We're rocking.
At least you can start with that, can't you?
We can. So what's next for Pullman's? Because you've gone from that small little office with a back room to how many sites have you got now in the UK? 5.
Well, 6 actually. If you include Scotland, which at the minute is not a Pullman lab. It's run as a separate business, but they do support one of the contracts that we've got with one of our bigger clients.
So are you buying that out, or is that already bought out by you?
I think at some point in time it will just get merged into Pullman. It will. I think it will happen eventually.
Right.
But this year, I think we'll probably end up merging buying another 2 businesses.
And have you seen those businesses on the horizon?
We've been talking to them for 3 years now.
Okay, and is that something that you're physically driving?
No, Nathan's doing this.
Right, okay. So who's Nathan? I don't think I've ever met Nathan.
Nathan's Colin's son. He owns the business.
Right, okay.
So he runs Flowmont. So Flowmont's the business at the end. Nathan, that's his day-to-day baby.
That's his baby. Right.
He has very little to do with Pullman's, because the first thing he'll tell us is, I ain't got a clue.
That's your job, Mark.
Me, Mark and Tony have got to run this place. And I guess I'm the one that's accountable if it fails. Yeah. But I don't want it to. It's not going to fail. It's a growing.
That's my mindset.
Concern.
Yeah, that's my mindset. MS Welding is never going to fail.
You know, and each year, each month of each year, we just keep going. You know, we've got customers that have worked with us for 25 years.
And are you finding new ones that are every bit as good and loyal?
I think you've got to develop it's about relationships at the end of the day, is this, Barry?
It is.
You can bring a customer on board and actually they don't know you. They don't know who you are, what your values are, who you are, what you like as a person. But actually when they've worked with you for 2, 3, 4 or 5 years and they kind of get that it's a relationship-driven thing, this. It's not
it's a family.
Just...
It works both
It's not just based on invoice values.
I agree. That's how we run. Completely.
Then I think that relationship to some degree changes.
I think the relationship in business is more important than the invoice. We need the invoices to keep the business running.
Yeah, but
the relationship,
you can't do anything without a customer.
You cannot do anything without that customer relationship.
Yeah.
And the understanding of both parties.
Yeah.
You know, if they phone up and they go, Barry, I need you now, and you're like, I'm already 300 miles away today, but I can get
it's
to you.
It's not that I can't.
I can get you in 2 days. I'll be there in 2 days.
Yeah.
You know, I am willing to push somebody in front of somebody else at times to help that customer out. And I'm sure you guys do that as well when somebody's screaming and you think I'm already a week behind him where I should be. Sometimes you've got to pull the stop out and say...
That's kind of one of the reasons why it makes sense to... We had 2 options. 10 years ago, probably more like 8 years ago, I think we myself, Mark and Nathan, because Tony Cox has just come on as a director in the last couple of years. But at that time, Nathan was saying, well, what's our 5 years, 3 year, 8 year, 5 year, 8 year and 10 year business plan look like? And we had a discussion around it, and it was, we did try it in Scotland. We set up a new office, it was just a room in Glasgow. We'd got a rep up there. And what we wanted him to do was go around and generate work, bring the work in, send it down here, we'd calibrate it. Did it for 2 years, 2.5 years. Didn't work. Because actually, if you're starting from brass tacks, it took us 25 years to get to a point where we were comfortable. Surely you'd think it's going to take another 25 years to do the same. So we just thought, well, Nathan, and I agreed with him, he just thought, well, actually the sensible thing to do is buy established companies.
Right.
Because you don't have to do all the legwork. There's legacy work that already exists. And nowadays, I think there's a lot of companies that have realised that that's the way forward.
So you acquire?
You buy the skill set, you buy the time served in the industry.
Database,
you buy their compliance, their accreditations. And that's kind of put us in a position where, so at the minute 6, but by the end of this year, I would think maybe 7, if not 8.
And you're one of the biggest global UK one of the biggest UK players in calibration at the moment.
If we bring those labs on board, then yes.
Yes.
As an independent lab, yeah.
An independent lab, and I think that's a really important part. Single owner. Independent,
not tied to a group or organisation.
Wow.
So it's his money. It's the efforts of everybody that works here that's kind of got us to where we are.
So, and where are you currently finding new engineers and stuff like that?
We're struggling with engineers. It's hard.
That's industry wide, and that's through a lot of different industries as well at the minute.
I'm loath to say it, and I don't want to use the word COVID, but I think it's damaged the generation. People they didn't have to work, and it's then difficult for them to want to do it because they didn't have to do it before.
I never thought about COVID in all this situation.
They got paid to stay at home, Barry, and you're asking people who have been given the privilege to get paid to do nothing, to then start having to think, well, now I've got to get off my bum and do something. And
I guess I haven't looked at that because I worked through COVID.
Well, I did too. We didn't get any time off.
My dad worked. My dad were like, well,
we couldn't stop.
No.
The industries that we are in, NHS, Network Rail, all of those, you couldn't turn lights off.
No, we couldn't.
They told us absolutely you can't
Yorkshire
turn lights
Water,
off. Yeah.
British Gas,
all
nuclear.
the utilities, yeah.
One of the first things with COVID is the nuclear establishment got in touch with me and went, Barry, right, listen, just to let you know that we're still going to continue. And if you come here and you end up with COVID while you're here, there's a bed here and you'll stay here and we'll look after you in quarantine.
Yeah.
And we'll look after you until you're clear and you can go back to your dad.
Yeah.
And my dad was like, that's mental, isn't it?
Yeah.
And because my dad worked 7 days a week because he didn't want to go anywhere and get COVID because his immune system was so suppressed by the drugs that he was on.
At least he was protected where he was.
Like, I'm just going to go to work. I'm just going to lock myself away. And my mum were like, why didn't he stay at home with me? And he was like, I'm safe there. Nobody's coming in unless our Barry's vetted him first. And they're going to deal with him before me.
Yeah. I don't know if people see it the same way that I do. But
it's a very interesting point.
It's damaged a generation of people. And where, if you try to run a business and you're trying to grow and you're trying to entice people, to take the opportunity it's a career path, is this? Yeah, it might not be in what you'd consider. I don't know. To me, it's interesting because you get to play around with lots of different toys.
I think it's a brilliant job.
But not everybody sees it that way. And then you're going to ask somebody to see it the same way that we do or find it interesting. And pretty much all that we've seen is that it's very difficult to find somebody who's got that appetite for it.
My customers, especially one of my biggest customers, are having a difficult time actually finding people who want to weld.
Yeah.
So we're seeing a major increase in people buying cobots, which again, that's a whole different conversation in itself. But
Are they robotic systems?
Yeah. So what they class as a cobot is something that can work alongside a human.
Right.
Now, that might be okay in a car factory where that cobot puts a wheel on.
Yeah.
But we're equipping these things with a welding torch.
Yeah.
That's got 1 or 1.2 mil wire sticking out the end and gets red hot.
Yeah.
And I've got this argument where there might be lots of motion control built into that cobot so it knows if it's touched you and it's going to stop all motion, but it doesn't know if the wires pierce your skin first.
Yeah.
Or pokes you in the eye first.
Yeah.
So I've got.
So there's no vision systems attached to it where AI can interrogate it.
I'm completely not convinced that the cobot systems right for the industry at the moment.
Right.
I'm not saying it's not going to be, and there's loads of people putting
it's a
welding.
work in progress. Yeah.
There's loads of people putting welding machines on cobots, but I'm just me. If something goes wrong, it's just me. And I'm not convinced that until we have got that implementation of AI being as good as we want it to be, I don't think it's right. But we've got people buying them at extortionate amounts of money, where they're not really suitable for the industry necessarily to start with. Very limited amounts of training because there's only a few people in that company to maybe train those people. And then that training is diluted. And although people think, there's a robot and it's welding those brackets together, because somebody wouldn't want to weld 300 brackets together. It's then got to be reprogrammed for another bracket or another job. So they don't fit into every kind of.
Whereas a human is very adaptive to its environment and surroundings.
Instantaneously.
Yeah.
Can you make that, Mick? Yes, I can. Yeah. And he's going to get on with it.
And it don't matter what it looks like. He already knows in his mind what he's going to do.
And we seem to have lost that. And I don't know if that's a generational thing. If you ask my son, Oliver, at 14, can you visually see this in your head? He'll go, what?
Yeah.
And he won't.
Yeah.
But I think the COVID thing's really, that's a really good point. Because we can't get people to weld. People don't want to weld for some reason. But I was thinking it was the welding industry that was at fault.
It's across the board. Doesn't matter what, I think it doesn't matter what industry you're in. There just is some reticent about having to go back out to work. After
we've paid them to stay at home for all that period.
And I'm not criticising anybody for this. And at the end of the day, this was a compulsion thing. It was a global thing.
Nobody knew what to do.
Nobody knew what was coming. Nobody knew. I don't even think we knew how to deal with it.
We didn't, and we don't now.
We were really reacting on the fly. But the thing is, I just see that there are catastrophic effects that I think are going to be felt for the generation to come.
And the generation's a long time.
Yeah, 20 years.
And
20 to 25 years of dealing with because all of the. The depressive side of things and,
that's starting to really show itself now as well, isn't it?
Yeah, isolation and, and then it's not just that. People have actually got used to working at home and now they're being told to go back in office and they're getting stressed about it.
Yes.
So honestly, there's so many, contributing factors to what the next 10 years are going to look like for the workforce.
And that could really harbour growth for a lot of people.
I think it is going to impinge growth. I do. I do think it's going to be unless we can start making sense of the need to. I was listening to something on the news yesterday about the UK's GDP.
Right.
So our gross domestic product.
Yeah.
And how they measured it. And actually, they're very creative about how they produce the numbers.
Right.
And they said the more accurate way to do it would be to look at GDP per person.
Okay, that's interesting.
Right, because that actually reflects what's going on in real time in the workplace.
Right.
But if you looked at that, our GDP figures would be through the floor because there's 4 million people not working.
Yeah, which is a big amount of people not working.
Which are not contributing to that GDP figure.
Yeah.
So you look at it and you think to yourself, okay, how much more successful, productive, stable as a country could we be if there were more that were thinking to themselves, well, actually, my responsibility is to contribute.
And is there anything that you as a company are trying to do to entice people in? Have you?
I'd love to say so, Barry, but I'm not sure that we are. It's just, again, it gets down to being to some degree distracted.
Yeah.
Yeah, it's hard to find the right people, to find the right fit. We've been very fortunate. We've just employed a chap who's now looking after running the lab.
Okay. Here. And what was his background?
He was an ex-military man, worked for Filtronics. So He's got a technical background, but he was also a very good administrator and he was a QA manager. And he's made a massive difference to what's going on in the lab. Massive difference. He kind of gets what it is that we're trying to do. We've had a number of people try it and they've failed.
Do you think his military side is something that's really helped?
I just think his attitude towards work.
Right.
His analytical and system-driven mindset is also helping.
Good.
He asks the right questions. Why are you doing that? You know, is there not a better way? You know, and actually sometimes you do need disruptors that ask those sorts of questions, because I'm too entrenched in a business. I've worked here 42 years. Maybe I aren't the right person to think about where we need to take this, because I've got my own ideas.
Yeah, and your own emotional attachment as well.
Emotional attachment. They might not. Quite often they are, but that's not the point.
Yeah.
It's good to have somebody that's actually going to second guess or question some of the things that we do, because actually it might take for somebody to think there's a better way to do this.
Yeah.
I mean, we're looking at some stuff now. We've just changed the way we quote our work. We're looking at ways that we can speed up work that we do on some of the rail industry stuff to actually get it moving through the business a little bit faster.
Right.
Because when you're dealing with volumes of work, time's a critical factor.
Yes.
So if we can make wins where we can save time doing things a certain way, the business benefits, and so does the customer.
What's coming in the next 10 years?
Oh, crikey. Retire.
For you.
No, I don't. I won't retire. I'll be like your dad.
Is that what's going to happen? You're going to be like my dad, and you're going to be there till the very end?
If I stay fit and healthy, I'm 57 this year. I have no aspirations to not work. I reckon I'd last a week.
That was a fear of my dad's.
I'd last a week and I'd be crawling up. Look, my wife would want me out of the house. She'd be kicking me out.
She'd be kicking you out.
Get lost.
You're
getting on my nerves.
I don't think I'll ever retire. I just, like you say, you kind of forget about the invoice when you enjoy what you do.
Yeah, so I kind of think of myself as a piece of rock. If you cut me down middle, it'd say Pullman inside. You know what I mean? It's just that, and I'm not the only one that works here. There's a couple of us that I would say very, very similar.
Through and through.
Yeah, we bleed it. We eat, sleep, and bleed it. Really,
it's brilliant. So where can people find out more about everything that you do?
So there's a lot of social media going on at the moment.
I've noticed your newsletter. That's something you've been doing. Yeah,
newsletter's going out. We're doing some drivers on new equipment that we're selling, combustion analyzers. We've got disciplines that we're trying to promote. So the high vacuum, the torque side.
Oh, because you built a torque.
Yeah, torque multiplier. We've got some torque suspension beams that we now use for calibrating torque meters. There's quite a few new things that we're advertising. We're having some pushes in the aviation industry, because that's a sector that we're kind of getting a lot of.
Is that a sector that you've not really worked in?
No, we've got some good work. We've done some good work.
So who do you work for in the aviation?
So it's more smaller airfields. So, people who look after lighter aircraft. We do some small carriers as well.
Right.
So they'll have a fleet of small Learjets or something like that.
Right, okay.
And we look after their equipment that they use.
Did you once bring us something from an airfield to look at?
I can't remember.
And didn't it sample air quality in plane or something like that?
I can't remember.
You always
listen. There's 60,000 units I see here.
Loads of different bits that you brought into me, Dad, over years.
I can't remember, Barry.
I think it's going to be funny when I go back to work now and I look at that transformer that my dad built one for you as well, and I think I forgot.
Pullman label on it. It'll remind you every time.
Oh, it's brilliant, is that?
Yeah. But I really don't. I mean, the next 10 years for us, if we grow in the way that potentially we could, so those two new businesses, there's 32 members of staff, so we could.
Wow.
That'll pretty much nearly double our size in 12 months.
And in 12 months, no time at all.
No time at all. So I think we'll end up looking at splitting the country. We'll have a north and south divide,
Okay.
I might look after the northern part of the business. And
maybe travel down once a month.
I think that there'll be two of us that'll probably look after the business.
Right.
I do suspect two. I know it'll be.
Right.
I mean, obviously, I'm not going to speculate, but I do. And it would make sense to do it that way.
Fantastic.
And then what we can do is we can actually look at what the development, because the funny thing is, right, we're quite, I wouldn't say aggressive, but we do chase work. We'll find it. We won't wait for it to come.
You've been very proactive on the finding of work.
Yeah, we have to do.
Yeah.
Growth doesn't come through expectation of repeat work.
No.
because customers control their assets and they could decide that actually we're going to shift everything onto a 2 or 3 year schedule.
Or we're not going to deal with Pullmans anymore.
How do we know what that is going to look like?
You're never going to know.
So we do have to be proactive in actually thinking, okay, we've got to still grow. We've got to build our customer base. But these other labs that we've bought, they're not aggressive in that way. They're not.
Right.
So we've got some work to do to actually bring them up to the same sort of
make that
mindset.
Aggressive.
Yeah. Be more willing to commit to actually go out and find it.
Getting out, finding
knocking
it. Knocking on doors.
And that's another thing that I think has changed, because I see in the industry, you can't talk to a real person. You can't ever get into a business.
And that's frustrating, isn't it, for a user? If you can't talk to somebody or you can't come through the door.
And yet my mindset has always been, we're looking at each other eye to eye now. That's how you do business.
Because that's that right back to the very beginning.
Feel.
It's a personal feeling, and it's the...
I'd rather look somebody in the face and tell them what I thought, or tell them what it is that I'm trying to do
even
for
a proper
them.
telephone call.
Yeah.
Rather than an email's got no value in some
emails
ways.
Can be ignored and forgotten.
And there's no sense of exactly what you might be trying to put forward.
Yeah, exactly.
You know, the passion that you've got, the passion that you have for what you do, and all the stuff that, and what we spoke about today is only a very small part of what you do.
Yeah.
And the passions still come through. Yeah. And somebody speaking to you about that, which is, I think, one of the reasons why I thought so much about you forever. I was thinking on the way, you know, if there's anybody that wanted to speak to about calibration and technical stuff, it would be Mark.
Yeah, I love this sort of stuff. So I see that we've got opportunities to continue to bring new systems on board to enhance what this business looks like to a known and an unknown client base. Because obviously what we're trying to do is we create a profile, we present ourselves. If we present ourselves as a solution to their needs,
a solution provider.
Yeah, that's what we do. That's ultimately that's what we are.
And that's what we say. I'm a welding solution provider. Welding solution provider for the welding industry.
Yeah.
You know, be it calibration or validation or repair.
It ain't just about shifting a box or delivering a service. Often it's about, okay, I've got a problem, what can you do for me?
Exactly. So
we did a project with Northern Trains. They were all this, you know, everything, the diesel costs and everything were going up. So they were asked to actually, we don't know what our emissions looks like on the trains, the old trains and the new trains.
Right.
And they were having to do something. I think they were having to look at changing the diesel filters so that they could bring the CO2 levels down.
Okay.
And there were also some new Euro changes to the CATs, and things like this on the trains. But they had no way of testing the diesel outputs, the emission outputs.
Yep.
So we knew of a company and we already sell their products. And so I kind of said to them, well, look, we have an emissions analyzer that we already know CAT in America use to test all of their lifting and shifting gear.
Yeah.
And there's no reason why the technology wouldn't be applicable to measuring diesel emissions on a train. It's at the end of the day, it's an exhaust.
Yes.
And you're measuring your sulfur dioxide, your nitric oxide, your nitrogen dioxides, all of those nasty volatile gases.
You're going to measure them exactly the same.
The unit can sample it in exactly the same way. And I think up to press, they've probably ordered 4 of these now. So
okay.
They're pretty much on their fleet of where their workshops are, their service centres. I think they're going to have one based in every service centre, so they can actually do the proper emissions test. So when your car gets MOT'd, you've got to do an emissions test.
Sure.
So they're now doing the same thing on the trains. And actually declaring what that emissions value looks like.
Are you responsible for recalibrating those?
Yeah, we do that. We do that.
What do you do? Do you buy
calibration gases?
And you buy nitric acid, CO2?
Yeah, all mixed in a gas bottle, and then we have to just create a stable flow in a controlled environment.
And then you measure it, and you know what's in that bottle.
Yeah, it's already pre-calibrated, gold standard.
The bottle's a gold standard,
yeah.
So you're going to work to that.
It's got a certificate that's attached to it.
You're happy with that certificate, and then if your machine reads, you're happy that we've got the right level.
Yeah. So again, it's just being in compliance with what the manufacturers stipulate.
Clever.
So, and it's exciting projects like that
Keep you driven.
It keeps your juices flowing. You know what I mean?
I agree. Keeps you driven.
It's nice to wake up on a morning and think, okay, what am I going to see today? And then you find yourself involved in something that you didn't expect to be, but it actually takes it in a nice direction.
And again, that only comes with, number one, relationships, but two, having a business that's willing to grow.
Yeah.
And expand.
And a lot of experience, I guess.
And learning.
4 decades is not...
Being willing to learn.
Long time. I'm still learning.
Me too. I love it.
Yeah, still learning.
I think that's the most important part, isn't it? And that comes with maturity. I love the level that I'm at now. Like, and I'm just hungry for it. Like, you said you're not that boring, but I really am.
No.
I will sit down and get the book out at home.
But listen, that's exactly how I learned. I used to take data sheets home. I'd read manuals. You know, there's nobody in this industry. You can't go to school.
No.
You can't learn what a calibration process looks like.
No.
They don't educate you that way. So realistically, at a young age, I realised that the only way that I could better myself was actually to educate myself, to actually start learning what it is that I needed so that I could make sure that I could do this job. So 4 or 5, it's probably about 5 years ago now, I actually did a business degree.
Was that purely for the business side of things?
Well, it was for personal gratification, to be honest.
Oh, brilliant.
Because I didn't... So, look, like I said, I've worked here a long time. I ain't got a flipping clue whether what I made decisions on were right or wrong.
Right.
But when I look back, they must have been.
Yes. There's a gut feeling.
But there was no substance that backed it up. So when I did the studies and I did the business degree, I kind of, it was interesting to look at it in a different way because I was relating my experiences to what they were saying. And I was thinking to myself, that's why I made that decision. Yeah. That's why we chose to do it that way. Now that makes sense. Right. So I came at it from a different angle, but actually it was a nice feeling to understand that a lot of those decisions, albeit a lot of them were common sense driven, were right.
Didn't happen by chance.
Didn't happen by chance.
No.
Something we got it right.
How long did it take you to do that?
4 years.
4 years. Did you do part-time, was it? Or?
Yeah, it was a workplace one. So one of these, funded MVQs. But basically it is a degree.
Amazing.
So it's I think MVQ 7 and 8 level that I... So there was me and Tony Cox that did it.
So you just did it here?
Took us 4 years to do it, home study. It was hard because you at the same time as running a business, you were doing a 10,000 word dissertation and essay. And
in a week, there's not a lot of spare time sometimes.
No, it was interesting, but we did it. So,
I wonder how many other people would do that. I think that's the next level of wanting to better yourself, but also you've calibrated yourself, haven't you?
It was about the next level of actually thinking, I need to prove to myself that I can do this.
And you've calibrated yourself. You've calibrated your own thoughts.
I've reset my parameters.
Reset your parameters. I think I'm gonna wrap it up because these podcasts kind of go on forever. But I think I'd love to have you back on. Like, I think it'd have to be a regular thing. And there's so many people that's come on early on. Sheldon from Fronius, he got like an hour and a half in, and like I was like, Shelley, people are going to get bored. We're going to have to cut it short, Shell. And they were like, I've not even got started yet. Yeah. But I think the value in today is just like the stuff you've spoke about is so interesting. And I think there's so many people in industry that will take so much from it, but not just my industry. And not just like these little bits about my dad, but also your industry and people and, customers learning about exactly what you do.
Yeah, well, we would love to offer our services to more customers. That's what we're here for. Well, everybody exists. Businesses exist because they want to support their staff.
Yeah.
We're nothing. Pullman's is nothing if it doesn't have the workforce that props it up.
Yeah.
My responsibility is to make sure that I keep bringing the money in so that I can pay them.
Pay everybody. And everybody's here.
And it's a mutual contract, isn't it?
Yeah.
And likewise, we entered into mutual contracts between us and our customers.
Yeah.
I am keen to try and get Pullman's promoted more.
Well, let's see what we can do, because I'm sure there's loads of people in welding industry that should be sending the stuff for UCAS calibration that don't. So let you know, they can contact you via the website. Where's that?
Yeah, pullman.co.uk.
It's just not Pullman Instruments,
No,
it's
pullman.co.uk. Yeah. And if they want to go on LinkedIn, we're on LinkedIn as well.
You're on LinkedIn as well?
Yeah,
well, that might be good because I'm on LinkedIn, so we can do some cross stuff.
Yeah. LinkedIn, we're on there. And we do regular, keep an eye out for, we're doing it every week. There's 2 or 3 social media posts that tend to go out.
Right, okay.
Quite regularly.
Right.
So, I'm guessing that you'll see those on the website anyway, because there's a link to them.
Right, okay.
And that, again, is just helping people to understand what it is that we're trying to do, where we're going.
Are they very informative? Are they almost educational posts?
Not enough. I would love them to be educational. I think they're promoting services.
Right.
But I think what I'd like to do is I'd like to put us in a position where we can talk directly to... I'd prefer to talk to somebody.
Yeah.
Contact us, talk to us.
I think those conversations are more important than any post that you're going to read.
Absolutely. Posts just... They're to try and get somebody to react.
To pick up the phone.
Yeah. They're a call to action, really, aren't
So
they?
if we can do anything, then it's about anybody in the welding industry whatsoever who needs something, new meters, they can talk to you and speak to you about them.
Absolutely. Yeah.
And you can discuss that with them and get the stuff
calibration
calibrated.
Needs,
absolutely. And the needs and requirements, you can discuss it with them then. And if they need their own procedures right in, or they need some help, or it's just a manufacturer's spec, it doesn't matter. You can come here and you can say, well, we've been doing Barry's stuff forever. We know he looks after nuclear stuff and ministry stuff, so we can always do it to the same level that we do it to FabBaz.
Yeah, absolutely. So, and I'd like to hope that they see that actually you kind of are rubber stamping us anyway because of the relationship that we have with you.
I wouldn't go anywhere. Like, there's number one, I'm always going to phone you and say, right, what do I need?
Yeah.
And it broke my heart in a way when Dad's old monocore.
That monocore had some history. It had some miles.
How many years did you?
We're nearly 20 years. 20 years old, Barry.
And it just looks so, like, I know it was vintage, and I put it. Who's the lad that comes and brings stuff with a big hair who comes to see
Josh.
me? Right, he brought it back and I was like, I'm putting it, just stay there, Josh, I'm putting it straight back on my dad's bench. And he looked at me as if I were absolutely crazy. I'm like, you're staying here.
It's posterity, is that thing.
It's got that horrible brown colour.
Yeah. That's the Austin Allegro.
It is Austin Allegro beige. It's that era.
It's that era, absolutely.
And it never let us down until it failed that final calibration. But I am so pleased that I bought my Fluke.
Good bit of kit. Fluke are great bits of kit.
I haven't looked at anything regarding software on it yet. I've just been using it, plugging it in.
It's got good data logging functions on that machine as well.
Really good.
Yeah.
And is it internal or does it need to be?
No. You can data log internally. It'll store it on display, and you can graph it as well.
Yeah, I've seen the graphing feature. That needs to be my weekend homework, Mark.
Yeah. There's some good that 289 is a good bit of kit.
I'm wondering how I can get I'm really confident with how I do my current at the moment because I've got 2 meters. I've got my clamp and my volts.
Yeah.
But I'd be interested in how I could maybe get my current even more accurate.
Yeah. Probably looking at the Rogowskis. They're more accurate. The Hall effect units.
Yeah.
And they're not interfered with by DC or AC.
Okay.
So if you've got high frequency, sometimes it can wipe the clamps out.
Right, yeah.
But the Rogowskis, they don't seem to react in the same way.
Is that because of how they're manufactured?
Yeah, just the technologies.
It's good, isn't it?
So, and they are quite accurate bits of kit as well. That might be the one thing that you do need to look at.
That and a new Matrel.
Yeah. Well, if you got your Rogowski, you could do away with your Matrel.
No, I mean my other Matrel for the safety testing.
Right. Okay. Oh yeah,
Yeah. Because we got the upgraded version, but there's a new one out now already, isn't there?
Yeah, they've moved on a little bit of those units. Yeah.
Because that's a really slow processor in mine. You can just see when you turn it on.
Yeah.
It starts ticking away.
They do some multi-testers as well that are quite heavy duty. That'll do all of the tests that I think you probably want as well.
You could probably, without using...
So look at CE Multitester on Mattel's website.
And have a look at that.
Yeah, have a look at that.
I will. I'll have a look at that when I get back.
That's a heavy duty, similar to a pack tester, but it'll do high current, so I don't know if you want to do any earth bond tests.
I do quite a lot of earth bonding testing.
Right, so it's all built into that unit.
All right. What's it capable on? Earth bonding test?
25 amps.
That's good, isn't it?
Yeah.
So I use it if I need to go like I amperage. I use my Robin.
Yeah.
You were the first person who ever taught me about pat testing.
I see.
You delivered my first pat testing course.
Training. I remember pat training course.
Before we go, I'll tell you this story about when my dad said, right, Mark's taught us, but we're going to get a qualification, and we went to night school to do pat testing. And I went with my dad, so we did a 16th edition together, and then we did his pat testing course together, and they bring like dummy plugs out, don't they? Or appliances with resistors in and stuff. Yeah,
so they create fault simulators.
So but you've got to imagine this situation. There's loads of people on this pat test course and they just want that certificate.
Yeah.
My dad were like, it's failed. Bazza, go get me a screwdriver. And he's stripping this vacuum cleaner down and lecturer comes over and goes, Malcolm, it's meant to not work. And my dad's going, yeah, but I want to know what you've done. He went, Malcolm, right, just leave it. You're not fixing it. Yeah. And that one, my dad, he'd have fixed it in college if he could have done.
Yeah.
Another good story. But thanks for coming on.
Welcome.
When are you coming back on? Couple of months?
Yeah, just get in touch and tell me when you want.
Brilliant, mate. I've really enjoyed it. Thanks for coming on and thanks for chatting about my dad, and we'll try and get this out for his birthday.
All right.
It'll be a brilliant one, mate.
Yeah, send me a link to it.
I will. Yeah, we'll do it, mate.
All right.
Cool. Brilliant. Thanks a lot, Mark.
Thank you, Barry.
The Weldlight Bazza podcast is sponsored by MS Welding, the #1 welding solution provider. mswelding.co.uk.